students here wanting to go at 1 o'clock, so I'll just keep going and I'll video this, okay, for you guys.
Thank you.
No dramas, thanks.
For the last 5 minutes, when you just finished, it wasn't show the picture that you're showing on the top.
Oh, really? Oh,
Yeah,
that's a bum.
when you talk about the
And I was doing such a good job. Sorry about that.
No,
and I did that specifically for you.
To test
So
whether
painful.
I'm a focus.
Yeah, I don't know anybody else had that same problem. We certainly had no issues here. We could see it online, and it had it now. Yeah. From a video perspective, I know that it doesn't video. Like it won't be in the recording, but I thought you might be able to see it. But anyway, I apologize.
No problem.
Makes it a little bit more difficult. Yeah, okay. All right, well, I'm going to discuss about timber floors, and we're going to start doing that, and if we get to do concrete floors, we will, but hopefully you guys can see that on your screen at home. And I'll just need to get my thing here. Here we go. So this is I just talked to you a second ago about 125 Centon piles. So this is really what this is about, Centon pile, concrete pile. So that's a Centon pile there, 125 by 125 pile. Okay, so the purpose of the subfloor inspection is to ensure that the buildings and building elements are able to withstand a combination of loads, and really it's what I'm talking about is exactly what B1 says, withstand likely loads, including wind. So it's a structural item. Okay, so those piles are a structural item. Then it also has a issue related to durability. So the building code durability is also important here. Okay. Another one is surface water. Okay, so it's disposal of the rainwater that comes and it cannot enter the building, and then in addition to that, it says, like in 3604, you're not allowed to have ponding under a floor. So then F2, any noxious fumes or anything in relation to the materials, and if you think about the materials, copper, chromite, and arsenic. Arsenic in itself it'll kill you. All right, so it's what they call a carcinogenic. So it produces cancer. All right, so if you're cutting with these, you're cutting any of this, you're doing any of the treatment of the timber, you've got to have your gloves on, you've got to have a mask on, and sometimes the guys don't even do it. So from an inspections perspective, I'm looking around for a brush, I'm looking around at the color of the timber, whether it's been treated or not. Okay. The reason being is the treatment doesn't go all the way through the timber. The treatment is pressured into the timber, but it's only 20 to 30 millimeters inside. So they paint the end of it, right, to actually finish the treatment. Okay. Yep. So F5, again, it's pretty much one of the codes that's always related to pretty much everything, construction, demolition. Okay. And H1 efficiency. So that is the insulation in the floor. All right. So that's a good picture there. So there will be insulation in the floor. Really interesting picture too, because that's snow. Right, and those are not conventional piles. They are special engineer piles. right? So you'll have special engineer piles. You can get these in New Zealand now. They just screw into the ground. There's steel, and then you just bolt the pile, sorry, the beam or your bearer to it. So it's quite a smart way of building, and quite attractive, because it means that you can move the house and then unwind all the piles, and you've got yourself a nice fresh bit of dirt, which you can do whatever you want with. Okay. So as I said, in relation to the siting, check your corrosion zone, identify the grade of the fixings that are going to be required. Okay. Ensure that adequate access is provided. So just while we're on that subject about durability, theoretically, the pile is a structure, then why is the piles galvanized? Because galvanizing doesn't last for 50 years. It's a protection of the steel. The reason that is if it's enclosed and it's not exposed to the spray or whatever, it's hit by the subfloor and stuff like that. That's how they get away with that concept of stainless. But then in saying that, there's also a conversation that goes anything within 600 of the ground. Okay, that's in 3604, the acceptable solution. It has to be stainless. Anything beyond 600 doesn't have to be stainless. So that's the cleared ground. Are we saying that if you were going to use the acceptable solution, are we saying that that pile up to at the 600 point stainless, and then beyond that it's just galvanized? Or is this must be special engineer design by an engineer who can come up with a solution? And obviously they have, right? Now, because you can get this in New Zealand. This picture, I think, is an American picture, but you can get those piles in New Zealand. And so how have they come up with their durability? I don't know, but they have, right? They're allowed to use them. Okay. Okay. So adequate access, is it provided? So again, another rule in 3604. It says that you've got to have a minimum of 450 to get in to the underneath of a subfloor. But what it doesn't say is the whole thing has to be 450. So, and the reason, see how the gap is there? That ability to get underneath and crawl underneath. So what it says is you only need to be enough 450 for servicing pipes underneath to check like your shower area or your toilet or any fixtures, any fixings, right? So in actual fact, you don't have to have 450 over the whole lot, but there is some minimum requirements on the manufacturer's specifications. So for example, the manufacturer specifications on plywood, if you're going to use plywood flooring, they will not guarantee anything closer than 550 millimeters. So the gap from here to the underneath of the flooring has to be, dependent on the product you use. So so you're not only restricted by the 3604 rules, you're also restricted by the manufacturer specifications and the thing, right? Polythene is required under the new Healthy Homes Act. So this is an interesting point, right? So the Healthy Homes Act of 2019 only kicks in if this house is to be rented out. But if this house is not to be rented out, you can't pin your ticket on that. So therefore you don't have to, but most people do put polythene underneath this floor. When we're talking about it, polythene on the dirt, and they tape it around the piles and so on, and it prevents the moisture, the bulk of the moisture coming up. Moisture does come through it, but in a controlled manner. So you have a choice as a customer, as a homeowner, on what way you want to go down. Now, if you're possibly going to rent it in the future, you'd do it, wouldn't you? If you want your baby, like my daughter, she had asthma. So while I want the best for my daughter, I want to make sure I do it to prevent the moisture coming into the house. I do it because it's the right thing to do, not because the Healthy Homes Act of 2019 asked me to do it. So it's got nothing to do with it. So from the perspective of me inspecting it, got nothing to do with me. There's another bunch of people that do inspections for rentals. All right. So just bear that in mind. Yep. Then there's a thing called damp proof membrane. So I'll try my best for you students online to see if I can find my little, please help me. Yes. Brilliant. All right. So, well, that's a good, so you see that point there, that's the point where if that was a timber pile, there might be a membrane, a bit of plastic that goes between the pile and the bearer. So this is, where are we now? Yeah. So that is only required if that distance is 300 or less. Okay. So 300 millimeters or less. Beyond 300 millimeters, it doesn't require it. And the reason being is that naturally water wants to track up. It's called osmosis, right? So the water sucks into the timber and then it sucks up. Okay. That's why I was saying to you earlier, we want to keep an eye on making sure when these piles are cut that they seal the top of them. All right, because the water does track up the wall. All right, so that's why you have that little bit of membrane in there. Okay, right. Oh. 300. Yeah. So, yeah, you can have, yeah. No, you can, in some instances, but you have to do that, you have to put membrane in between it. You have to protect it, right? So, and as I said to you, or you were out of the room at the time, you have to have crawl space, right? And if that's 300 mil, that's less than, it's 150 millimeters less than the crawl space. But the crawl space is only for to get to the shower, to get to other areas. So you can have areas of down to 300. You can actually go down to, so 3604 says you're allowed between 150 millimeters and 300 millimeters. But if you are, so the lowest you can go for your pile is 150. All right, so there's 150 and then there's dirt there. Okay, now that's pretty low. Okay, but it will only be like for, say, that top corner of the building. Like it's not going to be the whole lot, because that's just, but if you had a situation where you were coming into a hill and you're allowed to have it like that. So that's also the same for decks, right? So decks you can see a lot of, in the sense of them having 150 mil of ground. They're just a hideous thing to inspect and look at. But from the perspective of design, they look really cool. because you know, you can build up the soil and you can actually have a flush go from your deck out onto the grass and stuff. So yeah, you're allowed in 3604. You're allowed to do that, okay, but not for the whole thing. Yep, and then the subfloor ventilation is generally checked later unless the foundation. Yep. So what I tended to do was I would say to the builder, can you just ring me once you are at the stage, and I'll pop out and I'll do all the brackets and I'll do all of the checking underneath the job, all these brackets that I have to check just there and all that type of thing, and just stand on top and look down, because you know, I don't want to be crawling around underneath the building when I don't have to. You know, I'm not paid the big money like the plumbers. So, yep, and yep. So they can always put the brackets. So then what can happen is then they can put the insulation in. I can actually do the insulation in the floor. We can put the baseboards on, so the job can be ready to put the frames up, and it's quite attractive, you know, and it's clean and tidy. But you know, not a perfect world. So imagine living in an environment like this. So it's like, you know, I don't know, yeah, I'm just saying that the moisture coming up through that, you know, amazing, eh? Yeah. So subfloor inspection can be undertaken independently or in conjunction with framing inspection, and the outcome of the inspection is recorded on the framing inspection record. So I'll show you later or tomorrow. When conducting a subfloor inspection, it's important to compare the completed work against the approved plans to confirm framing and bracing requirements. Of course, my boss would always go, did you check the consented plans, Carl? Did you check the consented plans? Are you checking the consented plans? Over and over and over and over again. Because, of course, you see one house, you've seen them all. And, you know, like, there might be some plans there, but it might not be the consented plans. And that's that risk that, you know, you've made a mistake or something like that. And anyway. Okay, so yep, looking at that picture again, and we've got the issue of durability. Be cautious to check the durability of the fixings that are within 600 of the ground. As I said to you earlier, are they supposed to be hot dip galv or is it spray zones? All exposed fixings must be stainless regardless of the height of the ground fixings, including exposed hot dip. Oh yeah, partly because, so I said to you before, so this is this interesting thing is in 3604 it tells you about durability, it tells you about stainless fixings within 600 of the ground. If not, then after that it can be just normal hot dip galv, right? Then Carters or whoever the timber manufacturer, they'll put in another requirement. So whatever the requirement to the acceptable solution trumps, if Carters demand that all of the fixings have to be stainless and you're using Carters products, then you've got to use basically your stainless fixings. End of story. Because they are the ones that are, you know, coming up with the solution. Because, you know, there's ongoing debate about plywood on the inside of a house. Are the nails supposed to be stainless steel or are they supposed to be galvanized nails? And I don't know whether it's been resolved, but anyway. Yep. So yeah, wire dogs, bolts, brackets, nails have a durability issue when it's exposed to CCA treatment, which is copper, chromite, and arsenic, and it basically corrodes the steel. Okay, and it's not allowed to corrode for 50 years. All right, there's piles. That's the piles I was telling you about. No pile can be cut less than 300 millimeters into the ground. However, this may be reduced to 150 if you use a damp-proof course, which is essentially a bit of plastic, black plastic, all right, polypropylene, between the pile and the bearer. Okay, so yep, so looking at that picture, that's your pile, that's your bearer. Okay, that's your pile, that's your bearer. And above, so what you've got here, that's your pile, that's your bearer. And then above those are joists. Okay. Okay. So in this situation, adequate crawl space must be maintained and the surface area of the ground should be protected by placing polythene over it. The polythene should be installed prior to the rest of the framing and fitted tightly over all the piles. It can be lapped and taped in place to prevent movement. This is cut and paste straight out of the Code of Practice, all right? But it's exactly out of 3604, all right? Piles must be, so the treatment, so I've talked to you about H1.2. I've talked to you, maybe you've heard me talk about H3.1, 3.2. Okay, you've talked to me, there's another one called LOSP. Okay, this one is in the H family. It's called H5. Okay, H5. So it must be H5 if cut, and the surface should be treated with preservative to protect the timber. The packing between the piles must be installed, so you're allowed to pack. You know, if you've got a problem, you can pack in between there, but the packer has to be H5. And the cross-sectional area, that's this area you're talking about here, can either be 125 square or 140 diameter. Okay. Okay. Oh, yep. And then that's, yep. Okay. An engineering certificate must be provided for driven piles. So here's a guy driving piles there. Okay. And that's exactly what we just saw with Josh. Right. So in that one there, it's quite interesting. You've got, this is in Motueka or Blenheim or somewhere like that. I don't know whether I've got the video for it. Like the section has, like Josh talked about, did he say 75 piles? Was it? How many? 72 piles. So in this situation, it might have been 40 rammed piles, and then there was another 20 or 30 drilled piles. So they would drill and they'd pour concrete in and then do it that way. So they chose two different ways to achieve the same ends. Maybe the ground was too sloppy for the other one. It just meant the piles would just go forever. So yeah, yep. So yeah, there's a point here. So the maximum height for piles in the rule book in 3604 is 600 for what they call an ordinary pile. And then there's 600 for anchor piles. So that's how high they're allowed to go. 1.2 meters for a thing called a cantilevered pile. 1.5 meter for concrete piles, and 3 meters, so that's probably what these ones are, for braced and ordinary piles. Okay, so cantilevered piles would be, the joists would hang out like so, past, the building might be built out here, so that pile there is carrying the cantilevered weight, the extra weight that's hanging over and out into the air. All right, so that's what that cantilevered means. All right, and now these ones down here are a great example of a 3 meter pile. So you're allowed to go 3 meters, but you do have to brace them. Right, and yep. And then there's this, so if you go back to here, So you probably can't see it, but on these piles here, they look like they're standard piles, but actually they're more than likely these piles, anchor piles. So an anchor pile is going to tell me, come on, you bugger. Where are you? Ah, there we are. Sorry. Okay, an anchor pile is one. Okay, imagining a house. That's the top end corner, that's the bottom corner. There's another corner, and that's another corner. Right. Now there's still a pile here and a pile here. And so the rules in 3604 says, I think it's 6 meters centers, right? So you have to do bracing every 6 meters. So let's just say that's, and I'll add another one here for the purpose of what I'm doing. So it's one there, one there, one there, one there. So this building's 6 meters wide and it's 12 meters long. So therefore that can be an anchor pile, that can be an anchor pile, that one there, that one there, and that one there. You still got these other piles in between. You've got one there and you've got another one there, but so they're just standard piles. The difference between an anchor pile and a standard pile is that anchor pile goes 900 into the ground. So it goes deeper, all right? Whereas the standard piles go, 200 into good ground, right? So it only doesn't go very deep at all, okay? And the other advantage, so I've got to try and find there it is, okay, is that, so watching here, so the anchor pile braces in this direction and in this direction. It has the ability to twist, okay? So it means that if you just use a standard pile, you would have to have a lot more bracing in your floor. So the idea of using an anchor pile is that you reduce the amount. So you can look at over here. I'll try. Yeah, here we are. So look at these, the amount of brackets that you have to put on, right? So you don't want to be doing that too often. You've got to reduce the amount of work. Not that an architect thinks about that, of course, right? From a builder's perspective, he has to do the work. So he's more than likely thinking about it. And so, yeah. So that's so that's the concept of why people use anchor piles. It is to reduce the amount to give the same strength, but reduce the amount of brackets and everything and the work that's involved. So what you're looking for is you'll see that stamp actually on the bit of timber. All right. So yeah. Oh, 102. Okay. Come back tomorrow, team. All right. Thank you. All right. See you tomorrow morning, guys, online.
Thank you.
Thank you, Carl.
All right.
Thank you.
Carl.
Cheers. See you guys. See you.
See you tomorrow.